Okay, this is the second video in this short series devoted to variations on the Hummer principle. So as you can see, I have cards of various values, suits, and colors. So we'll go ahead and gather these. Now, since we both saw the cards, let's go ahead and just mix them so that no one knows where anything is. So if you're able to track these, kudos to you. So I'll go ahead and just really mix these. In fact, you can tell me right on left, right on left, okay. And then we'll give it something called a Klondike shuffle. Boy, does that make a mess of things. It takes the top and bottom card off as one. Brings those together, okay. So if you've been able to keep track of all of those, wow, you are a savant. Okay, so what we're going to do now is I'm going to push off 3 cards, and then I want you to tell me leave or flip, and I'll kind of build up a pile that way. So leave as is or flip? Flip, okay. Wrote this one, leave, okay, leave, flip, leave, flip. Okay, very good. Why don't we go ahead and we'll do it for 5 cards at a time. Leave or flip? Flip, okay. And what about this set of 5? Leave as is. And then what about this set of 5 here? Flip, are you sure? What about the set of 3? Flip, okay, wow. We are really putting these cards through their paces here. So would you like to do any more of those? Just one more series of 3s and 5s. Oh, and I should also point out that a 1, of course, is an odd number, so you can actually just put down 1 if you would like. So that's safe too. Okay, so next 3, leave or flip? Flip. In fact, you can just set this one down as is or flip it. Flip it. Okay, what about these? Leave. Flip. Okay. Leave. Flip. Leave. Okay, wow, what a mess. So we're going to go ahead and just try to separate these cards the best we can. So what I'm going to do is I'm going to deal these out into 4 piles. It's kind of a good way to go. So there we go, and I'll go ahead and just take pile 1 and put it on top of pile 3, 2 on 4, so that we have a big old mess here. Okay. And so what kind of packets do you think we have now after all of that? Could anyone possibly know the organizational structure of these? What do you think? Okay. Well, I think I have an idea as to what's in each of these. So let's just, of course we can't see all of them. That's the obvious thing, right? Some are face down. But let me see if I can get a feeling for what's in each. Ooh, that's weird. These are all the same. Same? What do you mean the same? They're all different. Oh, they're the same in the number of letters in their names. 4 letters. What about these? These clearly aren't the same, right? Ace has 3 and 7 has... Oh, these have an odd number of letters in their names. 3 or 5. Well, let's check these first. Are these all 4-lettered? Oh, that's a jack. A 4 has 4 letters in its name. A 9 does too. A jack, of course, does. A king has 4 letters. A 9, as we mentioned, does. A 5 and a king. All of these have 4 letters in their names. What about these? Do these have 3 or 5? That's 5 and 8. You spell out 8. 7 has 5. 6 has 3. 3 has 3. 5, sorry. Ace has 3. 7 has 5 letters in its name. Ace has 3. 3 has 5. And 8 has 5. We did it. We perfectly separated them into even value names and odd value names. How in the world were we able to do that together? Okay, so as I did in the first video in this series, I'm not giving you all of the deeper explanations as to what's going on. I will do that in the final video in the series, but right now I'll go ahead and just give you the mechanics of it so that you can actually perform this right away, even if you don't quite understand why it's working. Now, if you've watched the first video in this series, you'll kind of guess as to what the setup is. You can just gather these two halves here. And what we're going to do is we're going to put them in an alternating relationship relative to each other. Okay? Now, a slick way of doing that is just take each half in any order and perform a Klondike shuffle. That takes the top and bottom off as one, and if you just give it a moment or two of reflection, you'll realize that this is going to create an alternating packet where one card comes from cards with 4 letters in their name, and one card will come from cards that have 3 or 5 letters in their names. Okay? So this is an alternating cyclic construction. Well, because of that, you can randomly cut it. You can randomly cut alternating packets, and it won't hurt that characteristic. Better still, Charlier shuffle really makes it look like you're mixing the cards well, when in fact, all of the movement of the cards here is just equivalent to cutting the cards at some location, which is amazing. So I'll put a link to the Charlier shuffle in the description below if you want to take a look at that. And then from there, we began our flipping mixing of the cards. Okay, so as I mentioned, you can push off any odd number of cards. Okay, and that's different from the traditional Hummer principle. There, it's always an even number. Okay, so that's the important difference here. This truly is fundamentally different, even though it has a similar flavor to it, okay? So you allow the spectator to leave as is or flip, the 3 of those. Leave or flip, maybe they leave those. Flip, okay? Flip again, that's fine. Leave, and then flip, okay. But as I mentioned, you can do just one card, maybe flip that one, and then do these 3, maybe leave. You can even do 5 cards, leave or flip. Flip, okay, very good. And what about these? Leave, okay. Flip. Flip as well. Okay, very, very good. Okay, I do want to point out one little subtlety if it happens to you, because it could, theoretically, depending on how many cards you've chosen. I guess I should point out that we had to have an equal number, right? An equal number of cards whose names have 4 letters in them relative to the number of cards that have 3 or 5. Okay, that's the only way we could create our alternating packet. Maybe that was obvious. Okay. Now, it can happen that when you're doing this, depending on your packet size, here's, I'm pushing off 5, maybe you flip. Let's see, maybe I'm trying to think, well, I can force it, I guess. What I'm trying to do is I'm trying to end up with just 2 at the end. And if that happens, you just have to treat that a little more carefully. So here's 5. Maybe they'll leave those, maybe 3 here. And then, oh, here we go. So I'm trying to finish with 2. Maybe they'll say flip there. So if at the very end you have an even number, the only thing that you have to be aware of for this to work, and I'll talk about it in the full tutorial at the end of this series, is this one cannot, or it will ruin it. It will destroy things if you put it down as is. This even packet size has to be flipped before you set it down. So if you finish with an even number, just don't even make a big deal about it. Just flip it and put it down. I've never had any spectators say, why did you flip that one? You know? So anyway, that's the only kind of caveat or little warning to be aware of. Okay? Now, believe it or not, all of the movement of the cards has not changed the alternating nature of this packet. It has moved the cards around. The cards are changing position and places within the packet. But the alternation of cards with 4 letters with cards that have either 3 or 5 letters is preserved. Okay? In fact, let me just show you that to kind of build your faith, and then we'll separate them. Okay, so here we go. Here's a card with 4 letters in its name. Here, so think even or odd, and maybe that's easier. So this has an even number of letters in its name. This has 3, so it's odd. Even. Now we'll have to take a look at these. Okay, that's odd. Even, because it's 4. Sorry. Odd, it's 3. 4, it's even. Odd, it's 5. 4 is even. Odd, even. So they're not going off the screen here. So even. So this needs to be odd, which it is. It's 5 letters in its name. Even, because it has 4 letters in its name. 5, which is odd. 4 letters in its name. 5, 4, and then 3, which is odd. Okay, so this, if you compare this packet, the ordering of those cards, it's completely different from the one we started with. But that characteristic of alternating even name parity versus odd name parity has been preserved. Well, what does that mean? That means you can separate these into 2 halves that will have the very cards in them that we want. Okay, now there's lots of ways of doing that. Okay, and so I've shown you the left, right, left, right, left, right. That's great. I've also shown you into 4 piles, 1, 2, 3, 4, and you stack pile 1 on 3 and 2 on 4. That will do a wonderful separation. If you want to do an even or odd up jog, that would work just fine. So here we would just push forward, jog forward, the let's say the even position cards like that, and then you just strip those out and you're done. Okay, and then you can kind of show that. Now you know it's going to work because you've seen it work before and you believed me, right? Okay, so this is going to work just fine. I thought I'd better explain some of the mixing I did at the beginning, just to not go too deeply because we will have a full tutorial. But you can see we succeeded. These cards have 4 letters in their names. These have either 3 or 5. Okay. Now, if I'm not mistaken, I did a little bit of mixing at the beginning. So let me just quickly talk through that, and you can do the same mixing, and it's quite convincing. So now I won't reconstruct this, okay, as alternating. I'm just going to mention that near the beginning, well, we did a Charlier. Okay, so imagine that we're back at the beginning. We did a Charlier, and if you apply that to an alternating packet, it's still alternating. I also did a left-right. Do you remember that? Now, technically, what this does is it separates them. If they were alternating before doing this, now they're separated. It's one of the ways to separate an alternating packet, okay? And then we can randomly stack these, okay? So if you stop there, you're in trouble. You've kind of undone the cyclic packet that we need for all of this to work. But you follow it up with a Klondike shuffle. So I did an LR, it's called left-right, and then a Klondike, right? Well, this puts them back in an alternating relationship. Okay, so it really is just giving the illusion of mixing the cards, which it is in some sense. That's the important thing. The cards are being mixed, they're being permuted, but structure is being preserved or converted in a way that we want. Okay, so we're essentially back to the sort of thing that we started with. Okay, so just be aware that that's one mixing routine that you can do at the beginning to kind of convince the spectator that, boy, no one knows where anything is, right? And then from there, you just go through the procedure, right? Leave or flip and so forth, okay? And you can apply that to just one card, because 1 is odd, or 3 cards, or 5 cards, or 7, or 9, however many you like. It gets kind of tricky to count that many and not make a mistake. But so I would stick to 1, 3, or 5 just because of the feasibility of the mechanics itself. Okay, well, very good. Well, there will be another video in this series giving you a more advanced presentation of this variation on the Hummer principle that I'm introducing to the world here in this series. And then after that, we're going to go into an in-depth tutorial and mathematical look at what is going on, why does this work, and how does this differ from the standard Hummer shuffle and Hummer principle that has been out there for almost 80 years now. Okay, well, thank you for watching, and watch for the third video in this series where I'll go through an even more sophisticated presentation of this variation on the Hummer principle. So thank you again.